Concealed in tropical jungles and buried in arcane texts lie mysterious clues to man's forgotten military genius. Is it possible that the ancients discovered the basic technologies that produced one of today's ultimate fighting machines, the battle tank, hundreds or possibly thousands of years ago? Bulletproof armor invented for a war that killed a king and tore a nation apart. 5-ton armored beasts that crushed whole armies with fear and firepower. Armor-plated shock troops that smashed through enemy ranks. And strange, forgotten weapons that, like the tank, altered the balance of power on the battlefield and repulsed whatever the enemy could throw at them. Unlocking the secrets of ancient tank tech is our ancient discovery. The tank is built for aggressive attack, extreme mobility, and resolute defense. A frontline weapon in conventional warfare, it's considered a modern invention. But evidence recovered from the ancient world suggests that man has always strived to create weapons with the tank's basic attributes.
While the tank was invented in the 20th century, the ideas behind the tank, mobility, protection, and firepower, go back to the beginnings of organized warfare.
In India, in the 17th century, a weapons system that combined firepower with mobility caused havoc on the field of battle. The elephant, weighing 5 tons and capable of moving over rough terrain at 20 miles per hour, was conscripted for active service. It was mounted with a platform carrying heavy cannon, fired by specialist gunners.
The ancients understood what a tank was long before they had the ability to make anything that we would recognize as a tank.
Today, tanks combine tremendous mobility with the destructive capability of 125mm guns mounted in rotating turrets. But is it possible that the ancients used the same principles and technologies on the lost battlefields of history?
Throughout history, we get lots of stories about elephants and their use. But in a document from 1616, we get a really exciting, intriguing eyewitness account of elephants being used in an unusual way.
In 1616, a British traveller called Edward Terry reported seeing Indian war elephants armed with heavy guns, 6 foot long and mounted on wooden frames.
He states that Akbar, the Mughal king, was using cannon on elephant back. That turns an elephant from a mobile fighting platform and a beast of war, much as a stallion or a battle charger might be, to an animal-powered equivalent to the battle tank.
There is some evidence that elephants were used in battle in India as long ago as 1100 BC. Initially, their chief function was to give commanders a better view of what was happening on the field.
This is where the Indian kings would have stood in battle. They would have been up on top of the elephant, surveying the battlefield, commanding the position, flying their flags. This is a very powerful way of presenting yourself on the battlefield.
Commanders soon realized that elephants could also be used in the front line. Massed in hundreds, they charged down on the enemy. The air was filled with dust and the deafening sound of their trumpeting. The ground trembling beneath their feet, elephants were a truly terrifying sight.
The elephants themselves were trained to pick up horses and riders in their trunks and dash them to the ground, to their ruin. They also had their tusks sawn off and fitted with tusk swords, and one such looks like this. This fits on the sawn-off end of the tusk, so that instead of the natural end of the tusk, you have this double-curved blade with a huge, fat, armor-piercing point at the end, which would make a fearsome square wound in anything it hit.
Their function on the battlefield was to smash through the enemy general's lines and wreak havoc on his order of battle.
They will break the enemy's formation. They will cause chaos in the enemy's front ranks. They will give you an opportunity to cross the ground, to attack the enemy hand-to-hand on your terms.
Sometimes elephants carried archers. Such specialist bowmen required years of practice, not to mention a fine sense of balance. But the discovery of gunpowder changed the strategy and tactics of elephant warfare. Between the 16th and 19th centuries, the Indian subcontinent was dominated by one of the greatest states in history, the Mughal Empire, ruled by the Emperor Akbar.
Akbar was the third of a highly successful series of Mughal rulers of India. He was around in the 16th century. He was known as a great military innovator. He was driving for technological advantage over his enemies in an effort to hold sway over the vast part of the Indian subcontinent.
The British traveller to India, Edward Terry, is specific about the weapon he saw on the elephant's back.
This is a conjectural reconstruction of what Terry describes. First, he uses the word gun.
Mounting a cannon on its back would transform the way an elephant was used in combat. Each animal would become a mobile artillery unit. The gunner would have a 6-foot height advantage, giving him enhanced range and visibility. Experimental archaeologist John Naylor has arrived in the jungles of Southeast Asia to investigate the advantages and disadvantages of this ancient tank. But before mounting a weapon on the beast, there were other problems to be solved. John is investigating each one in turn.
That's it.
The first problem was weight. At the time, heavy cast bronze cannon were in general use. The elephant cannon demanded iron, which was 20% lighter than bronze.
This is much lighter than a bronze or brass piece, coming in at about 400 pounds.
The second problem was the difficulty of reloading. Most guns in the 17th century were muzzle loaders. The gunner had to walk round to the front and shove the powder, wadding and missile down the front of the barrel.
Obviously, if you're balanced on an elephant, you can't walk round to the front to ram the charge home and load it.
Cannon forged of iron and not cast in bronze can be constructed with a rear opening called the breech. The missile and the gunpowder are packed into a separate cylinder, effectively a giant bullet. This is slotted into the breech, which means you can load the cannon from the back rather than the front. The final problem to be solved before mounting the gun is to work out how to aim it. Elephants can't turn on a sixpence, so to be effective, the gunner would have to aim the gun without changing the direction of the elephant, exactly like the revolving turret on a modern tank.
The key to how you aim these is in the swivel and the pintle. Just by having it being able to turn left to right, to pan, and to tilt on this point of balance means you've got lots of flexibility in aiming.
But to find out how to aim the elephant cannon in practice, John must mount up. From his lofty position as an ancient elephant gunner, John now appreciates the tactical advantage of this ancient tank.
The first thing that's amazing about this is the field of view. I can see for hundreds of yards all around. So for a commander, this is excellent as a command point to actually see the whole layout of the battlefield. This is an awesome weapons platform.
To test the targeting accuracy, John has modified his replica cannon to fire paintball rounds. Real explosives and real iron cannonballs cannot be used in case they endanger the elephant or John himself. Practice targets have been laid in a clearing on the edge of the jungle, exactly the same terrain that the commanders of old preferred.
Here we go. Yes, that's dead. It's a real learning curve. It's working out the movement of the elephant, the movement of the gun, and the movement of the target in relation to both.
John has discovered the knack of the ancient aiming technique.
I ended up more like a naval gunner, learning to wait for the point where the gait of the elephant is in line with the target. As a weapon system, I think we've shown that it would have worked, especially against packed infantry. You add in bows and other weapons in there, grenades and all the rest of it, armour everybody up. This thing would have been devastating.
Over the centuries, weapons became more powerful, armour became more sophisticated, and elephants themselves developed through selective breeding and training. Nevertheless, elephants survived for over 1,000 years as the frontline war engine of many imperial armies. But it was not only animals that laid the foundations for today's tank tech. Throughout history, sieges have been a forging ground of military innovation. Ancient Discoveries investigates an armored fighting machine that battered a nation into submission. The capacity of a tank to smash through obstacles on the battlefield and defensive walls is essential to its effectiveness. This capability was also at the heart of the tank equivalents of the ancient world, siege engines. These varied from 300-foot-high armor-plated siege towers to trebuchets that could fire flaming missiles over 1,000 feet.
Siege technology is a very advanced, sophisticated thing in the ancient world because of the inherent difficulties of breaking into defended places.
In the 2nd century AD, the Roman Emperor Trajan led a campaign against the Dacians, a tribe that lived on the northern frontier of the empire.
Trajan was a new emperor wanting to make his mark. The way you did that as a Roman emperor was by winning military glory. Under the previous emperor, Rome had suffered a series of defeats at the hand of the Dacians, and they'd become almost a traditional enemy.
The war is chronicled on Trajan's column, which still stands in Rome today. The relief sculptures on the pillar depict versions of a simple yet cruelly effective siege weapon, the battering ram.
It's so simple. It's what the police use if they want to bash down your door. They batter it down. And you want to attack a castle, well, you need to bash the walls down or bash the gate down.
The largest battering rams weighed perhaps 3 tons. They were normally hung on ropes from the roof of a wheeled wooden frame. Teams of soldiers used muscle power to swing the ram back and forth, gradually building up enough momentum to smash through wall or gate. To protect the soldiers from arrows or stones dropped from ramparts, the solid oak frame was covered in wood and animal hides. The problem was, wood and animal hides are flammable. Defenders could pour burning oil onto the ram's protective covering, burning the shelter and incinerating the men beneath. The attacking engineers came up with an ingenious solution: chemical fire retardant.
The material that was used was alum, and this was used to prevent wood burning.
Alum is a naturally occurring rock.
It's a mineral which contains aluminium, and this is a particular rock here from which alum can be extracted. This is alunite.
Chemist Nicholas Norman is using alum to cook up some ancient fire retardant.
The way in which they would have extracted alum would be to heat this up for long periods of time in air and to keep it moist as well. And the physical effect of that is to turn the rock into a powder, and that dissolves in water. That could therefore be painted on things like wood.
Alum works by cooling the fire chemically.
A reaction takes place which actually takes heat in, an endothermic process. And the effect of that is to take the heat out of the fire, in a similar way to water does.
Ancient model maker Richard Windley has been reading the texts. He wants to know whether or not alum really works.
What we want to try and do is to do an experiment using alum, and we're going to soak hessian or canvas in an alum solution, and then once that's dry, what we're going to try and do is to set fire to a piece of the untreated material and the treated material and see what the differences are.
The canvas on the left is treated with the alum fire retardant. That on the right is untreated. Using a replica historic flamethrower, Richard puts the chemical to the test.
Hopefully we'll be able to see that the alum-soaked canvas is fire retardant, if not fireproof, and we expect the other canvas to char and burn.
Richard's flamethrower uses a combination of sulfur and charcoal to produce flames heated to 1,000 degrees.
It's just starting to burn. It's not burning very fiercely, but we are getting a definite burn there. It took about 1 minute 25 seconds to get that burning. It's not burning that brilliantly even now, but it's definitely been damaged.
How will the untreated canvas compare?
That one seemed a lot quicker. We got that one burning in about 27 seconds, and it's actually burning away, so it's fairly evident that this is the actual natural canvas.
Fireproofing using alum worked better than anyone expected.
It's several minutes now since we applied the flame to the second piece of canvas, and as we can see, it's actually burning away now, and it looks as though it'll keep on burning until it's pretty much gone now. Whereas the first piece, which is the alum-treated one, it's almost extinguished completely. There's almost no further sort of degradation or burning has taken place since we removed the flame. So all in all, this is relatively an impressive demonstration of what was capable using this alum treatment.
The superiority of Roman siege engineering resulted in victory after victory. Within 4 years, Trajan destroyed a whole nation. He exterminated the Dacians and repopulated the empty land with Roman settlers and pensioned soldiers. It became known as Rome-ania, and it's still called Romania today. From the Roman siege to the contemporary battlefield, all military engineers faced the challenge of combining firepower and protection with mobility. The medieval equivalent was the knight.
This is a trained killer encased in armor, and he is a medieval tank and riding through the front lines of a battle line.
The plate armor of the medieval knight is often considered bulky and cumbersome.
There is a myth that knights were winched onto horses and lots of people were needed to assist them to their steed.
But new discoveries show that the armor of the medieval knight was more advanced and sophisticated than we thought. A training manual written in the 14th century offers intriguing evidence that the fully armored knight was in reality a highly mobile and agile assault weapon. The text is believed to have been written by an intrepid French knight called Boucicaut. He tells us that as part of their rigorous training, knights in full armor practiced leaping onto the backs of their horses, climbing walls, and even performing backflips.
When you put a suit of armour on, it can be quite restrictive for the first time. It's very heavy, and as soon as that helmet comes down, it's very claustrophobic, and if you're not used to it, it's very, very daunting at first. So knights used to train religiously in order to get, used to it before they went out on the battlefield.
The secret of how the plated body armour allowed knights such freedom of movement was articulation.
Articulated armour is steel armour that joined together with rivets to enable the wearer to be encased in armour, yet still move freely. It's very important that the plates are very close together. Full movement can be maintained during combat without failing.
The metal joints and rivets in full plate armour mirror the joints in our bodies, so that they move smoothly with the actions of the knight as he moves.
Actually, wearing the full plate armour, you are still very agile and you can still do pretty much anything any normal man can do.
Expert horseman Carl Ude Martinez is preparing for the ultimate demonstration of the knight's agility, the joust.
On a joust, you need to be able to really move quite well. You've got to be able to control your horse. But not only are you holding the reins in your left hand, you've also got a 12-foot lance in your right hand.
A full suit of plate armour worn by soldiers in the 14th and 15th centuries weighed on average about 60 pounds. This is lighter than that which a typical soldier carries into battle today. For the joust, this light military combat suit was often reinforced with heavier, bolted-on protective plates.
Your midriff is protected by the biggest part, the chest and the back. That joins together with a strap. Then the cuirass is this bit here, the lathe bit, which enables you to sit in the saddle and is very articulate. That protects from your waist down, basically, and the tops of your thighs. And then I have leg armour on the bottom. As we move up to the top here, as you can see, my shoulder and my elbow protection is in two parts, enabling me to move my arm around. If it was in one part, I'd find it very hard to move this left arm.
The most minutely articulated parts of the armour were the gauntlets or gloves. Each gauntlet might contain hundreds of rivets and up to 60 articulated separate tiny pieces.
These gauntlets that I'm wearing here is probably a very good example of how articulated the armour had to be. You can see that there's several layers to this. It's not just all one rigid piece. Fingers had to be very mobile in order to clutch hold of weapons, swords, reins. You can see there's about 10 lathes there, and you can see I can move these very, very easily.
The skills of war were also those of the joust. Mounted knights like Boucicaut, who was renowned as a master of the sporting tournament, charged at their opponents, thrusting before them a 12-foot lance. It could kill or disable with one blow.
Judgment time, I guess. I'm going to be galloping at 15, 20 miles an hour in a straight line with a 12-foot pole. Somebody else is going to be doing exactly the same. So we're going to collide at 30 to 40 miles an hour. The impact is going to be strong. Now it's time to put my trust in the armour that the knights wore from the medieval era.
The medieval lance was 12 to 14 feet in length. It was made of wood, usually ash or oak, and had a sharp metal tip made of iron or steel. Its origins are as old as military horsemanship itself. It began as a heavy spear designed to kill enemy horses and their riders. But for sporting tournament jousts, the head of the lance was fitted with a crown-shaped metal cap instead of the lethal point. The purpose of this was to allow the lance to catch onto the shield, making it easier to unhorse the opponent or break a lance on him, actions that scored highly under tournament rules.
I can move at quite fast speeds in this armour. You know, you really forget about it, and your main focus is on the target coming towards you. I'm able to move my body, take my lance across, and I'm able to get my shield out. So I'm actually very mobile in the saddle.
The combination of the protection afforded by fully articulated body armour with weapons like the lance, together with the speed of the horse, turned the knight into a formidable attack weapon on the battlefield. Used against foot soldiers in open combat, the knight in full armour reigned supreme for several hundred years.
By the end of the 15th century, the armourers had cracked it completely. They could make beautifully articulated armour of steel plate, fully hardened and quenched, of the very finest imaginable quality. And if you could afford it, you could be safe on the battlefield from all the weapon systems that were around.
The armour plate was so beautifully articulated that when NASA began to research the hard-shell spacesuit for the first moon landings, they looked to the 15th century armourers for their inspiration. Although armour plate did not go into space and astronauts found other more advanced materials, the story of plate armour is not over. In recent years, patents have been filed in the United States, and the American Department of Defense is once again investigating articulated Kevlar armour, although the results are still top secret. As with every successful military innovation, articulated armour's supremacy on the battlefield was eventually challenged by a new technology, the gun. But as we will see, the armourer's response was ingenious. The medieval world's answer to the gun was bulletproof armour. New X-ray photographs will solve the mystery of how ancient engineers created this life-saving military gear. Amazingly, they reveal that the technique is identical to that used on a modern tank. Today's armoured fighting vehicles are protected by duplex armour, in which two layers of metal combine to absorb or fragment the impact of projectiles.
In front of me I have two slabs of armour which improve the ballistic protection from incoming projectiles. As time moved on, we discovered using heavier and heavier slabs of armour would just take away the effectiveness of the vehicle itself, making it slower, harder to handle, less effective generally. So we started to use composite armours made up of several different layers of different materials, air gaps, or materials such as glass or ceramics, because essentially they're lighter.
But duplex armour is a much older concept, one that in fact dates back over 300 years. In England in the 17th century, an arms race decided the fate of the monarchy. A war was fought between the royalists, who supported the king, and the parliamentarians, who supported a republic or commonwealth. The English Civil War left 850,000 dead in battle. In the main, the high death toll resulted from two deadly weapons, the crossbow and the gun. The standard issue gun from the 15th to the 19th century was the musket.
Guns have been around on the battlefield since the middle of the 14th century. Simple smoothbore muzzle-loading matchlock guns, which could nonetheless blow a lead bullet through the middle of any armour that any armourer could make.
But towards the end of the Civil War, armourers came up with something that reduced the effectiveness of both gun and crossbow: bulletproof armour.
The armourer's art has evolved over hundreds of years, and every time a weapon is developed to penetrate armour, it's the armourer's job to defeat that and create something that will stop penetration.
Earlier attempts at making bulletproof armour struggled to get the right balance between protection and mobility.
Armourers could make bulletproof armour, but nobody wanted to wear it. It was getting heavier and heavier, and they were constantly seeking ways of getting round the problem of the weight.
Ancient Discoveries investigates how the armourers of the English Civil War unlocked the secrets of lightweight, bulletproof armour. It's a journey that begins with a set of discoveries at the Royal Armouries in Leeds. While X-raying a number of breastplates made in the 1650s, researchers uncovered intriguing evidence that the armourers were experimenting with technology that was far ahead of its time. They were using duplex armour.
Well, one of our most exciting recent discoveries has been these duplex breastplates.
And they're clearly an experiment that was going on in the middle of the 17th century to make lighter bulletproof armour by doing multiple layers of metal in a single piece.
But the X-ray revealed an entirely unexpected feature.
We can see here the outline of the two breastplates crimped together around the edges. But also, internally to this, we have a third piece of armour.
This third layer was unknown before these X-rays were taken.
And this is actually part of a pikeman's leg arm. It's what's known as a tasset. We can still see the rivet holes in there that help us to identify its function.
The breastplate is reinforced by leg armour, astonishing proof that English armourers were using triplex systems. But because of the lack of ballistic data from the period, the true effectiveness of duplex and triplex armour against 17th century firearms remains unknown.
We have no ballistic data about shooting bullets at these things because the problem is that we don't really want to shoot bullets at historical objects and destroy them. And I suspect the manufacture of replicas and testing of those, as close as we can to the real thing, might be the best way forwards.
Martin Bavin, a replica armourer, is doing exactly that. Using the same tools and materials that were available to English Civil War armourers, he is recreating the tank-like armour system.
The armour that we're recreating, I would say, bears a lot of resemblance to the modern armour used on tanks today. It's obviously evolved a long way and they're using much finer materials, but in principle, the techniques and the idea is the same.
To counter the increasing power of firearms, armourers sought ways to make metals stronger. The repeated heating, hammering and cooling of ferrous metals like iron changes the crystalline chemical structure into a much smoother one. This renders the metal harder, tougher and more flexible. The process is known as tempering.
We've got here the inner layer, the central layer, replicating the pikeman's tasset that we can see on the X-ray, and then finally the outer layer.
The final piece weighs 10 pounds. It's 17 inches high and 13 inches wide, very similar to the Leeds breastplate.
We've built this armour as closely as we can to the original from the illustrations and the X-rays. Weight-wise, I think we've got it around the same kind of weight, so hopefully the metal is thick enough.
The armour has been brought to a ballistic testing facility at Cranfield University in Bedfordshire, where it will be tested against the firepower of a musket and a crossbow.
This crossbow is actually a goat's foot lever crossbow. To load the crossbow, you need to put the goat's foot lever on the top. The crossbow is now cocked and ready to fire. And you place the bolt on the crossbow, and away to go.
The goat's foot device uses a lever which enables the warrior to draw a more powerful bow, double the power of many ordinary bows, up to 350 pounds of draw strength. But even this enhanced super crossbow cannot penetrate the armour. Today, the crossbow does not seem as deadly as the gun, but in the Middle Ages, it was considered so lethal that in 1139, Pope Innocent II banned its use.
Well, the armour seems to have performed quite well here. The crossbow has dented the armour, but the dents are not very deep and really unlikely to have done anything more than give the wearer a fright. There's also no sign of any cracking there, so this armour seems to perform very well against the crossbow.
But how will the armour stand up to the gun? The team is resetting the laboratory for the musket, which will be mounted in a clamp and fired remotely.
We've got in front of us here today a matchlock musket from the first quarter of the 17th century, still in use up until roughly the 1640s, 1650s. It's called a matchlock because it's ignited by a piece of glowing match cord in the serpent here, touching loose powder in the pan, causing chemical reaction in the barrel, and then we get the projectile coming out of the end.
The team will fire a 20-bore iron musket ball out of the 42-inch barrel using 2 grams of gunpowder, the same measure of powder used by musketeers in the Civil War. With this amount of gunpowder, the musket has less kick than a modern gun. It could easily be fired from the shoulder. Nevertheless, the muzzle velocity, in other words, the speed of the musket ball leaving the gun, was 1,400 feet per second. Although deadly if you were hit at close quarters, the musket was not accurate, and its effective range was little more than 100 feet. So the prevailing battle tactic was for ranks of musketeers to fire their volleys all at once, and create a wall of projectiles flying towards the enemy, rather than individual soldiers singling out specific targets. This meant that whether or not an individual musket was accurate didn't matter, as hundreds of balls would have sprayed the oncoming forces with the same effect as a machine gun. The inaccuracy of the musket was overcome in an ingenious way in the battle for Nagashino Castle in Japan in 1575. The musketeers were vastly outnumbered by a superior force of heavy infantry and cavalry. The commanders ordered the front ranks of musketeers to carry 3 guns each, so they could let off all 3 in rapid succession. 3,000 balls, 200 pounds of fast-moving lead, spraying out in less than a minute, devastated the enemy forces, and the battle was won. However, the warriors at Nagashino Castle did not have triplex armor. If they had...
The ball hit the target and it took away 1 layer of the metal and pushed the other 2 layers into the body. Now that gave us quite a big bash, quite a hole, but it didn't penetrate. We've still got 2 layers of steel that have withstood the charge.
The massacre at Nagashino would have been prevented had they had English Civil War triplex armor.
Well, this is very similar to the way a modern armour would work, particularly a ceramic-faced composite armour, where it would use a ceramic layer on the front to spread the bullet out and disrupt it, and then a composite layer on the back to absorb the energy of the projectile, so stopping full penetration occurring.
Our experiment has shown that the use of multiple layers of metal armour is capable of resisting projectiles. The breastplate was an innovative, lightweight alternative to thicker and heavier single-layer armour.
One thing that triplex armour does prove is that armourers were constantly striving to upgrade their product to make the wearer a lot safer. And this actually shows that by using 3 layers of steel, it is possible to slow down or even in some cases stop musket balls or pistol balls.
Over 350 years later, the same principle underlies the latest developments in tank armour.
Weapons on impact will penetrate the initial layer, but then they'll explode into the air gap, rather than penetrating through the internal armour and killing the occupants.
However, advances in armour construction could not counter the threat of every new type of missile. Ancient Discoveries investigates a rocket-based weapons system that would not look out of place on today's battlefield. The ancient world's answer to the modern anti-tank missile. In the 3rd century BC, Alexander the Great conquered almost all the known world. Turkey, Syria, Judea, Egypt, and Mesopotamia had all fallen to the most celebrated commander, perhaps of all time. But in 326 BC, he came face to face with a new threat, the ancient tank.
When Alexander's conquest runs across into India, he comes across the kingdom of Porus, and he meets elephants in battle for the first time.
The Hydaspes River in the present-day Punjab region of India was the battleground. On one side stood 45,000 battle-hardened troops led by Alexander. On the other was King Porus and 50,000 Indian infantry, supported by 200 war elephants.
Even the best soldiers will be spooked by something as novel, as bizarre, and as awe-inspiring as the first tanks or war elephants.
So how do you defeat the ancient tank? The Shahnameh, a manuscript written in the 11th century by the Persian poet Firdausi, suggests that Alexander used an extraordinary weapons system.
There's a wonderful Farsi poem which says that Alexander the Great defeated Porus's war elephants by building large numbers of iron horses, which he filled with naphtha and then set on fire.
However, other sources report that it was Alexander's tactical brilliance and the heroism of his soldiers that won the day, not the burning of iron statues.
He wins the battle, and the elephants then come back into post-Alexander Hellenistic warfare.
Alexander had achieved what all commanders demand of their anti-tank weapons: to disable the weaponry, pierce the armor, or bring the whole attack to a complete halt.
The ability to take out the enemy's main firepower has always been paramount to winning the battle. If the enemy doesn't have his mobile firepower in his tanks or his elephants, he hasn't got the backup for his infantry on the ground. Therefore, you have a higher chance of winning the battle.
But Alexander's victory came at a high cost. The 12,000 casualties he incurred from Porus's war elephants left his forces unable or unwilling to fight on in order to complete their invasion of India. But a precedent had been set. War elephants could be defeated.
Elephants are unusual creatures, really, to use in battle. They don't like the atmosphere of the battlefield. They don't like the screams. They don't like the smell and the sound of death. And quite often these creatures would turn tail and, of course, actually storm straight through their own ranks rather than the enemy ranks, causing absolute chaos.
Military commanders soon began to deploy many kinds of anti-elephant devices that targeted the animal's vulnerabilities.
One particularly ingenious way the ancients came up with of panicking elephants was to coat pigs in tar and set fire to them. Elephants, unsurprisingly, get very frightened by self-barbecuing pigs heading their way.
These poor, kind of flaming porcine creatures would charge towards the elephants and send them off in a crazy stampede.
But 1,000 years after Alexander's incursion into the Punjab, India was still the center of ancient tank technology. The Mughal Emperor Akbar, in his campaign to extend into Gujarat in northern India, was faced with the same problem as Alexander. But now the world had gunpowder.
There's a battle between the Mughals and the army of Gujarat. The Mughals have quite a small army, and they're using a lot of missile weapons, artillery and rockets. And the Gujaratis are relying more on older technologies, the elephant in particular.
During Akbar's campaigns, countless rockets were launched by hand or mounted in wooden frames and set off. The weapons system was even said to target elephants specifically by skimming the rockets just above the ground.
In this battle, a rocket hits one of the elephants, and the inevitable happens. He stampedes, the other elephants stampede. A very large Gujarati army is defeated by a much smaller Mughal army using firepower and knocking out their primary weapon system. And this is the battle where the elephant really ends his reign on the battlefield.
The weapon that ended 2 millennia of the elephant's dominion over the battlefield was not much bigger than a large mouse. Rocket experts Ben Jarvis and Paul Birch are investigating how such a weapons system could have been deployed by Akbar's rocket artillery units.
From as early as the 13th century, rockets were being used by the military. It wasn't until the sort of 17th or 18th century that they had much more of a defined use. Rockets were generally used on the battlefield mainly as a psychological weapon, and were used for sort of scaring horses, camels and elephants.
The text describes the rockets as being 8 inches long and 1.5 to 3 inches in diameter. The canister of propellant was sealed at one end and strapped to a shaft of bamboo about 4 feet long.
This is basically a replica that we've built of one of the 17th century rockets. The casing here would have been made of iron, and it's bound onto a bamboo cane with this leather thong. The Indians were using iron-cased rockets probably before pretty much anyone else was. It has a lot of advantages over bamboo cases, for example, which the Chinese use, in that it's able to contain the explosive power of the gunpowder much, much better. So they could have packed more in and got higher pressure and therefore higher performance out of the rocket.
Ben and Paul have recreated a multiple rocket launcher.
We've basically got a rack of 8 replica Indian artillery rockets here, using gunpowder engines, same as the Indians would have done up until the 18th, 19th centuries.
Straw bales equal to the width and depth of 2 war elephants have been set up 120 yards away.
Using these sort of old bamboo canes and the same sort of technology that they would have used, accuracy isn't exactly guaranteed. So this is probably one of the reasons why they use quite so many rockets. Batteries of 8 or 10 would commonly have been used. On this test, we've got the angle we think about right. So we're hoping that these ones should be fairly accurate. We're aiming for a fairly straight flight.
How will the weapons system that ended the reign of the war elephant behave under test conditions? Seen here in 3D, the rocket's trajectories are wild and inaccurate, with no 2 missiles showing the same line of fire. But just as the ancient engineers must have found, testing the war elephant destroyer involves refining and endless retakes.
We're going to do another test of a single rocket this time. We've picked one that's got quite a straight stick. We've lowered the angle about another 5 degrees, so we're going to have another go, see if we can actually get it to hit the target.
Despite the team's recalculation of the angle the launcher should be set at, they're still finding it difficult to hit the target. Did the Indian rocket men know something that Ben and Paul have yet to find out?
The texts that we have about these Indian artillery rockets tell us that they were actually able to sort of hit targets with different diameter rockets and do calculations to work out what elevation. Having done all these tests today, if nothing else, it proves that they must have really known what they were doing, because it's proven a lot harder than I thought it was going to be to actually hit a target, even from fairly close range.
The team has now set the launcher at 12 degrees. They hope the straighter line from launch to target will give better results. While lowering the degree of the angle of fire has brought improved performance, 3 rockets having kept a lower trajectory, replicating the feats of the ancient Indian rocketeers is proving a very tough assignment. After firing more than 25 rockets, the team has decided to move the weapons system closer in to a range of 80 feet. Firing at closer range finally brings success.
Well, we finally managed to actually hit the target. If nothing else, we've learned today that these rockets really probably were very, very inaccurate, and in terms of actually hitting a fixed, let alone a moving target, it would have been very, very hard for them. If you're firing hundreds of them at a time, it only takes one of them to go even near a horse or an elephant, and the effect would have been devastating.
At this close range, the terrified Indian soldiers would have had to wait until the elephants were almost upon them before firing. Just like today, tank battles then were fought with technology, but won by the bravery of men.
I think there are brief moments when the elephant is the tank of the ancient and medieval world, but they're very brief because the innovative thinking of people like Alexander the Great, the Mughal emperors like Akbar, they very quickly realize that they have to neutralize this advantage which the enemy has, and they do so.
From fearsome armed elephants to bulletproof armor, the ancients' arms race to produce the most sophisticated assault and defense systems revolutionized the way wars were fought. Wherever the battle was waged, every general has called on his engineers and armorers to give him the upper hand in the conflicts that have shaped history. Ancient Discoveries has uncovered weapons technologies that not only defined the ancient world, but also laid the foundations for the machines that dominate the battlefields of today. BC. Initially, their chief function was to give commanders a better view of what was happening on the field.
This is where the Indian kings would have stood in battle. They would have been up on top of the elephant, surveying the battlefield, commanding the position, flying their flags. This is a very powerful way of presenting yourself on the battlefield.
Commanders soon realized that elephants could also be used in the front line. Massed in hundreds, they charged down on the enemy. The air was filled with dust and the deafening sound of their trumpeting. The ground trembling beneath their feet, elephants were a truly terrifying sight.
The elephants themselves were trained to pick up horses and riders in their trunks and dash them to the ground, to their ruin. They also had their tusks sawn off and fitted with tusk swords, and one such looks like this. This fits on the sawn-off end of the tusk, so that instead of the natural end of the tusk, you have this double-curved blade with a
55mm guns mounted in rotating turrets. But is it possible that the ancients used the same principles and technologies on the lost battlefields of history?
Throughout history, we get lots of stories about elephants and their use. But in a document from 1616, we get a really, really exciting, intriguing eyewitness account of elephants being used in an unusual way.
In 1616, a British traveller called Edward Terry reported seeing Indian war elephants armed with heavy guns, 6 foot long, and mounted on wooden frames.
He states that Akbar, the Mughal king, was using cannon on elephant back. That turns an elephant from a mobile fighting platform and a beast of war, much as a stallion or a battle charger might be, to an animal-powered equivalent to the battle tank.
There is some evidence that elephants were used in battle in India as long ago as 1100 BC.
Huge, fat, armour-piercing point at the end, which would make a fearsome square wound in anything it hit.
Their function on the battlefield was to smash through the enemy general's lines and wreak havoc on his order of battle.
They will break the enemy's formation. They will cause chaos in the enemy's front ranks. They will give you an opportunity to cross the ground to attack the enemy hand-to-hand on your terms.
Sometimes elephants carried archers. Such specialist bowmen required years of practice, not to mention a fine sense of balance. But the discovery of gunpowder changed the strategy and tactics of elephant warfare. Between the 16th and 19th centuries, the Indian subcontinent was dominated by one of the greatest states in history, the Mughal Empire, ruled by the Emperor Akbar.
Akbar was the third of a highly successful series of Mughal rulers of India. He was around in the 16th century.
Concealed in tropical jungles and buried in arcane texts lie mysterious clues to man's forgotten military genius. Is it possible that the ancients discovered the basic technologies that produced one of today's ultimate fighting machines, the battle tank, hundreds or possibly thousands of years ago? Bulletproof armor invented for a war that killed a king and tore a nation apart. 5-ton armored beasts that crushed whole armies with fear and firepower. Armor-plated shock troops that smashed through enemy ranks. And strange, forgotten weapons that, like the tank, altered the balance of power on the battlefield and repulsed whatever the enemy could throw at them. Unlocking the secrets of ancient tank tech is our ancient discovery. The tank is built for aggressive attack, extreme mobility, and resolute defense. A frontline weapon in conventional warfare, it's considered a modern invention. But evidence recovered from the ancient world suggests that man has always strived to create weapons with the tank's basic attributes.
While the tank was invented in the 20th century, the ideas behind the tank, mobility, protection, and firepower, go back to the beginnings of organized warfare.
In India, in the 17th century, a weapons system that combined firepower with mobility caused havoc on the field of battle. The Elephant, weighing 5 tons and capable of moving over rough terrain at 20 miles per hour, was conscripted for active service. It was mounted with a platform carrying heavy cannon, fired by specialist gunners.
The ancients understood what a tank was long before they had the ability to make anything that we would recognize as a tank.
Today, tanks combine tremendous mobility with the destructive capability of 120